Alright, so here we're going to look at electrical power. So what is power? Power is the rate of work done, right? Power is the rate of work done. So when you hear the word rate mathematically is equal to 1 all over time, right? Rate is equal to 1 all over time. So power is the rate of work done, right? It is the rate of work done. So of rate means what? 1 all over t, right? Of work done, right? W is work done. So your power, which is the rate of work done, it is 1 all over t of what? Of work done. So of in mathematics means multiplication. So if you multiply this will be power is equal to W over what? T, right? So this is power. Power is equal to work done over time. So it is the rate of what? Of work done, or it is the rate of doing work. So work done in electricity is equal to QV, right? Work done is equal to QV. So if work done is equal to QV, then power will be equal to what? Work done over time. That's QV over what? Over time. So this is a formula that is very important. Remember, QV is what? Is work done. So power is work done over time, QV over time. Then work done can also be equal to IVT, right? So if work done is equal to IVT, then power will be equal to work done over time, which is IVT over what? Over time. So this time will cancel our time, and that will make my power to be what? Equal to IV. So power is equal to IV. This is very important. Where your I represents your current and V represents the potential difference. Q is the charge, V is the potential difference, T is time here, right? Then another formula for work done is W is equal to I square ROT, right? I square ROT. So if work done is equal to I square ROT, then your power will be equal to work done over time. So your work done is what? I square ROT over time. So this time will cancel out this time. This T will cancel out this T. So that will make my power to be equal to what? I square R. So power is equal to what? I square R. So this is another essential formula that you can use, right? So power is the rate of work done. The formula is power is equal to QV over T. Power is equal to IV, or electrical power is equal to what? I square R. So these are the three formulas that you can use depending on the parameter that is given to you. So let's look at this question. An electric iron is connected to a 240 volt supply and takes a current of 5 ampere. Calculate the power rating of the iron. An electric iron is connected to a 240 volt supply and takes a current of 5 ampere. Calculate the power rating of the iron. So the first thing I would want to do here is to bring out the parameters in this question. So again, the question is, an electric iron is connected to a 240 volt supply. So this tells us about our potential difference. So the potential difference V is equal to what? 240 volts, right? An electric iron is connected to a 240 volt supply and takes a current of 5 ampere. So the current I is equal to what? 5 ampere. Calculate the power rating of the iron. So we are looking for the power rating of what? The iron, the power of the iron. So what's the relationship between power, current, and potential difference? So we know that power is equal to what? Power is equal to IVT over what? Over T, right? Power is equal to IVT over T. So when this T cancel out this T, what we now have is power is equal to what? IV, right? So this is the relationship between power, current, and what? Potential difference. And we looked at it here that power is equal to what? IV. So these three formulas are formulas that you must remember always. So power is equal to IV. So this will be equal to, my I is what? 5 ampere. So that will be 5 times what? The potential difference V, which is what? 240 volts. So 5 times 240, 5 times 240 will be equal to 1200. So my power is what? 1200 watts, because power is measured in what? In watts. So this is my answer to this question, right? It's quite simple and straightforward.